Hey everyone, going back to transformations of polynomial functions. Looking at the function that I've already have plotted, it's f of x equals x squared. Just this parent function for a quadratic function type. It is a polynomial because the exponent is a positive integer. We got a graph. This is f of x here. Here's a table for f of x. So whenever I do f of -2, I plug in -2 for x, and -2 squared gives you 4. -1 squared is +1, 0, 0, 1, 1, 2, 4. So what we're doing is transforming f of x according to this rule, creating a new function. I should probably have an f right there, so we know what we're transforming. G of x is going to be half of f of x minus 1 minus 2. So looking at this transformation form, we should be able to pick out a few things already. For example, the a value in that is a half, or 0.5 if you prefer. I'm actually going to change that to negative to make it even easier to see. So a value is actually -1/2. The h value is +1. Remember, the h value is just a tad bit tricky because the formula literally says x minus whatever h is. And then the k value, nothing tricky about that. It's just -2. So we should be able to tell just by reading the function rule that since a is -0.5 or -1/2, our function is going to reflect. It's going to face downward, and it's also going to shrink vertically. It's going to compress this direction. It's like we're smashing it this way. The h value of +1 means everything's going to shift to the right 1 unit, and the k value of -2 means everything's going to shift down 2 units. So what I'm really going to focus on today is making a function table to kind of make these values hopefully make a little bit more sense. And so to do the function table, nothing too complicated about it. We'll just go with our input values. And then we will have our function rule right here. So the rule is we're taking -1/2 of f of x minus 1. It's going to be pretty, really not that time consuming, I guess. So then we're looking at the value of g of x for our output. Okay, so the x values might not be as clear right now, but I'm actually going to start with -1. So when I plug in -1 into this function rule, let's see what happens. When I do -1/2, and I've actually got -2 down here at the end too. When I do -1/2 of f of -1 minus 1 minus 2, should be a 1 right there. I'm just like screwing up all over the place on this video. So f of -1 minus 1, that becomes f of -2. Maybe I should write this down. So on this one, I've got f of -1 minus 1, which means I have f of -2 there. Now, what is this value? What is f of -2? Well, we can go back to our original function to check that out. F of -2 is +4. So this really becomes f of -2, and f of -2 is +4. So now I've got -1/2 f of -1 minus 1. Remember, that just becomes +4. So -1/2 times 4, and then minus 2. So -1/2 times 4 is -2. And then -2 minus 2 is going to give us -4. So a lot going on there. Whenever I plug -1 into the function, into this function rule, in the function rule for g of x, which again I got from up here, it spit out -4. So let's plot that point while we have it. When I plug in -1, the function spits out -4. -1 Then I go down here to -4. All right, fantastic. Okay, so let's plug in 0, see what happens. So I'm doing -1/2 times f of 0 minus 1, and then I still have that -2 off to the end. So let's think about everything that's happening with this one. I'll do it right here. I forgot to write -1/2. Whoops. All right, so I've got -1/2 times f of, well, 0 minus 1 is -1. And I still have that -2. The k value off to the end. So f of -1. When I plugged in -1 into f of -1, right, of this function, it spit out +1. So f of -1 literally equals +1. And I'm still subtracting 2. So -1/2 times 1, well, that's just going to give me -1/2. And then -1/2 minus 2, I'll just convert that to a decimal now. That is -2.5. So when I plug in 0, the function's actually spitting out -2.5. So I go from 0 down here to -2.5. All right, so we'll keep going. Plug in -1. I think I said -1, but I meant +1. So for this one, when I plug 1 into this function, replacing this with 1, let's see what happens. So I've got -1/2 times f of, well, 1 minus 1, that is 0. So I'll do -1/2 times, hey, what is f of 0? We know what f of 0 is. F of 0 is 0. Then I have -2. So -1/2 times 0, well, that's going to give us 0. I still have to subtract 2, which gives us -2. So when I plugged in 1, the function spit out -2. You should notice now that all these values are negative because the a value is negative. It's reflecting this function. Anyways, let's plot this. I go over 1, down 2. We can do another one. If I plug in 2, this becomes -1/2 times f of 2 minus 1 minus 2. Once again, -1/2 times f of, well, 2 minus 1 is 1. Then I subtract 2. F of 1, hopefully you're able to read it from the table up here. When I plugged in 1 to my original function before the transformations, the function spit out +1. So I'll do -1/2 times 1 minus 2. -1/2 times 1 is -1/2 minus 2. And just like we did right here, essentially -0.5 minus 2 is -2.5. -2.5 is going to go there. Okay, so I go over 2, down 2.5 for that point. Let's do the last point with 3. So I'll do -1/2 times f of 3 minus 1. I'm running out of room here, so -1/2 times f of 3 minus 1. 3 minus 1 is 2. I'm still subtracting 2, that k value there. Keep on working. Try to find, well, what was f of 2? What was f of 2 originally? Before we started transforming the function, f of +2 actually spit out a +4, which you can get from the original table up there. And I still have to subtract 2 when I'm done. So -1/2 times 4. -1/2 times 4 is -2. -2 minus 2 gives me -4. -4. So for this last point, I have to go over 3 units and down 4 units. Okay, so hey, whenever I start to connect my dots, try to draw on the function, you should see that the function shrunk a little bit vertically, or I like to say, it widened. It reflected. Let's go through it one more time. So the a value was negative. So that's why it's facing downward now. It reflects it over the x-axis. The half just means that it shrunk vertically. I'm kind of smashing it this way by a factor of 0.5. The h value of 1 means everything shifted to the right 1 unit. And then the k value of -2 means everything shifted down 2 units. And that's why I have this point here. All right, so that's the idea behind transformations all in one. We did both we did an a value, an h value, and a k value. So what you're going to be doing in your assignments is just pick out the values of a, h, and k and describe in words what's happening. So describing in words would be, the a value shrinks the function vertically, it reflects the function, the h value shifts the function left or right, the k value shifts the function up or down. All right, y'all, thanks for watching. I'll see you in class. Bye-bye.